Hi, welcome back to another episode of Real-World Serverless, a podcast where I speak with real-world practitioners and get their stories from the trenches. Today, I'm joined by Michael Wittig, who is here to talk to us about how he's built a serverless chatbot with his brother. Hey, Michael, welcome to the show.
Hi, thanks for having me.
So before we jump straight into it, can you tell us a little bit about yourself and what you've been building?
Yeah, sure. So my name is Michael Wittig, and I run a blog that is called cloudonaut.io, where we focus on AWS topics. So it's not only focused on serverless stuff, we also talk about the old stuff, EC2, RDS, and things like this. But yeah, we do this since a couple of years, I think 5 or even 6 years. And I work together with my brother, Andreas. So we have published a few books in the meantime, video courses, and a lot of material about AWS. And we also run a serverless product that is called Marbot, and I think that's what we are going to talk a little bit about today, which is a chatbot that connects AWS like AWS monitoring with Slack and Microsoft Teams.
So Marbot has an interesting story as well. You guys did that as part of the AWS hackathon. I remember quite a few years back. And since then, you've added a subscription option to that. And it's been growing pretty steadily. And it sounds like it's doing pretty well.
Yeah, you're right. So in 2016, AWS launched together with Slack a hackathon where basically the job was to use Slack and the AWS APIs together. So we thought a little bit, okay, what could we do here? And we always had these problems with getting the monitoring data out of AWS, like for example, alerts or CloudWatch events and things like this. So if things go wrong, so how can we notice that? And also how can we make sure that someone picks up the task? So that's why we participate in the hackathon, and we also won a prize. But I must admit, there was not only one prize, so a lot of people won a prize. So we were one of the projects that was awarded with a prize. And since then, we continually improve the service and the features. So that's right.
So I guess given the domain that you're dealing with really event, so I guess serverless and Lambda is a pretty nice fit with Marbot. Can you maybe just give us a bird's eye view of how your architecture looks like from a very high level?
Yeah. So basically, we have two different sources that send us data. So the source number one is SNS topics or subscriptions within the client's AWS account. So if you set up your AWS monitoring setup, then you usually have an SNS topic where all those sources send their messages to. And Marbot basically connects to this with a HTTPS subscription. So that's the event source number one. And we also have the chat services itself. So Slack, the Slack API sends us webhooks, and also Microsoft Teams sends us webhooks. So those are all the inputs to the system, basically. And what we do is we accept this data on an API gateway, and then we move it to, or we put it on a Kinesis stream, and then we make sure that we process the events as fast as we can and do whatever is needed. For example, send a message out or get some data, fetch some additional data, things like this.
So are you able to share maybe some numbers in terms of the amount of throughput you're dealing with? Are you dealing with, hundreds of thousands of events per day or even more?
No, I think that's a good size, hundreds of thousands of events. So we sometimes have problems that people connect our Marbot endpoints with very chatty services. So for example, we have people that accidentally connected to an S3 bucket. So all the S3 events are then sent to us. So we sometimes have a lot of requests, and then we are well above 100,000 calls per day. And what we have done, because we don't really want to send that many messages to you in Slack. I mean, you will get crazy if we would do that. And also Slack will limit us because they have rate limits on their APIs. So what we do to protect this or protect our service and also protect basically you from going crazy by reading all those messages in Slack is that we are using the API key features of API Gateway and rate limit our APIs as well. So you cannot really send us that many events. And it also doesn't really make sense to send that many Slack messages. So that kind of goes hand in hand here.
Okay, and do you do any additional filtering to make sure that if you had the an event so about something, you don't send me another event about the same thing within, say, like a 5-minute or 10-minute or even 1 hour window.
Yeah, so maybe I can go or just take one step back. So at the beginning we thought, okay, it seems very simple to actually send a message to Slack. And in practice it is very simple, but there are many problems that can occur. So for example, what happens if the Slack API is not available? And at the beginning in 2016, this happened more than once a day. So the Slack API was not very reliable. It improved a lot today, but back in the days, this was one of our biggest problems. The Slack API was not available. And the next problem is, as you mentioned, it doesn't really make sense to send you 10 alerts that something is still wrong if you already received the message that it's not working. So what we built is 2 things. So first, we made sure that we actually retry until we can deliver the alert to your Slack window. And this is mostly done with the kinesis strategy. So if you cannot reach Slack, we just retry until Slack is up again. And the second thing that we build into our service is what we call alert aggregation. So for example, if we see that we have a similar event processed a couple of minutes, or we go back 24 hours if you like, so you can configure the window size, then we will just update the message in Slack and say, okay, this is now part of 2 or 3 or 5 or hundreds of events, to avoid sending you too many messages.
So you touch on the fact that some of these API calls you're making, including the Slack API, is not always reliable. Sometimes they fail. And it's just interesting that you're using Kinesis, this retry until success behavior with Lambda to basically get this retry out of the box. I remember when I spoke with Ben Cahill from iRobot a while back, they are also taking advantage of the fact that the Kinesis has got this retry until success behavior. So you recently wrote a blog post essentially talking about how do you deal with the fact that the more dependencies you have in your system as you integrate with Team and Slack and other services, essentially it's got a compounding effect on your SLA. So can you maybe talk to us a little bit about what the core problem is and some of the strategies you're using to isolate your dependencies and how to improve your uptime?
Yeah, so what we basically have as dependencies is, okay, the biggest dependency that we have is AWS. But the good news is that they are really reliable. So we don't see many errors with our AWS dependencies, Kinesis, DynamoDB, and S3. The other dependency that we have is Slack. And now, since we are added support for Microsoft Teams, we add the Teams API as well, which is called, it basically integrates into Azure. So there's a chatbot service, and you basically talk to the chatbot service, and the chatbot service forwards the messages to Teams. And when we thought about how we implement this, we didn't like the idea that our stable path from like receiving alerts and sending them to Slack, we didn't want to affect this by our new code and our new dependency Microsoft Teams. So we were trying to achieve a way to have those 2 channels independent. So if Slack is not working, we still want to send out alerts to Teams. If Teams is not working, we still want to send out messages to Slack. So what we did, we had this one Kinesis stream, which at the time only deals with Slack, because we only supported Slack at the beginning of the year. So what we did is we added a second Kinesis stream, and everything that was Microsoft Teams related basically sent the message into this new stream, and we had a complete separate processing unit to care about the Kinesis messages that are relevant for Microsoft Teams customers. So this way, at the beginning when we started the private beta, we had a few problems in our code mostly, and we had to fix them, but this all had no effect on our Slack users, because we had those 2 completely independent paths, data paths in our system, ensuring that a problem in one of those streams does not affect the other one. And that's something that I can highly recommend. So if you have if you're adding dependencies to your system, you will always decrease the availability of the whole thing, unless you can really make sure that they are isolated. And that's kind of the only chance that you have to make sure that systems with many dependencies have good availability.
Yeah, that reminds me of a lot of the practices that we've used in the past for things like priority queues and having one queue for every single ingestion, point, as well as every single outbound target as well. It's very much applicable here. But I guess one of the downside of this approach is that with something like Kinesis, at least, where you are not just paying for the number of requests you're making, but you're also paying for uptime. Is that something that you guys are potentially concerned about, that by the time you add, 100 different egress, then you end up having to have 100 different Kinesis, each one of them are not being used very much?
Yeah, so I agree. So Kinesis is actually our biggest cost driver, because we also use multiple shards, and not because we need them in terms of capacity, but also to isolate again within the stream. Because if we have an error in the messages, that they only affect one shard, so if Lambda cannot really process this message, all the other shards will continue working. So we have, for example, 4 shards for Slack. So usually we try to only have a couple of customers, or like a smaller amount of customers on each shard. So we pay a lot of money for Kinesis, and if there would be a more reasonable pricing model, for example, like DynamoDB on demand for Kinesis, so that would be a big benefit for us. The problem that we have, and we also thought about using SQS for our use cases, because as you mentioned, SQS is also a good choice to isolate the two dependencies, Slack and Microsoft Teams. But in our case, the problem is that we really need a order, because if an alert happens, then you can, for example, you can acknowledge the alert, you can close it, and those things need to happen in order. So if you close an alert before it was acknowledged, then things things become very complicated in the code. So we said, okay, we use Kinesis, and we know that it will be a little bit more expensive, but we get the big benefit of the order. So for example, we have orders within a channel. So we know that everything that happens in a channel is processed exactly in the order that Slack sent it to us, for example. And that helps us very much in the code. So it simplifies the code base, basically. But the downside is, as you mentioned, that you pay in Kinesis for the shard hour. So we have basically our Lambda costs are not really, I don't actually know. I think they are below $10 definitely. But for Kinesis, I think we pay maybe 500 or something like dollars per month. So in comparison, it really doesn't make a lot of sense. Also, if you compare it to what we pay for DynamoDB. So DynamoDB is also very cheap, so maybe the same range than Lambda. Kinesis is really the biggest part of our bill, and we would like to change that. And we are hoping for something that happens in the Kinesis service in the future.
Quite a few of the guests on this podcast have asked for a different pricing model for Kinesis in the past as well. I know Ben Cahill was advocating for that too, to have a similar pricing model to Kinesis Firehose, where you are paying for the amount of data that's passing through your stream rather than paying for uptime. But in your case, could you have used the SQS FIFO queue? Would that have worked as well?
So I think the first problem with the ordered queues is that they were not available in 2016. And also, I must admit that I think they added Lambda support. I'm not sure that this was maybe this year or maybe last year. So it's not integrated that well into Lambda as well. And also, I don't really like it because it has so many restrictions about throughput. So I think Kinesis is more, on the spectrum of make it easy to use the service, I would say that Kinesis is easier compared to the FIFO queues.
Yeah, the support for FIFO queues for Lambda was only introduced, I think, was late last year, just before reInvent. I remember because it was something that I've always wanted to use, but never been able to. So I ended up using Kinesis for a lot of things that could have been done with FIFO queue instead.
Okay. So what are your experience with those queues? Because I never use them. I always look at them a little bit with suspicion. So I'm not a big fan of them. But what are your experiences using them? Is it like working fine for you, or?
Yeah, it works fine. So with SQS FIFO queue, so you have to specify the group ID, and essentially it's the same idea as the partition key you send when you send to Kinesis when you publish an event. And additionally, you also have to, for FIFO queues, you have to specify how you're going to do the deduplication as well. So that's one of the things that the SQS that does that, well, FIFO queue does that Kinesis doesn't do. They gives you deduplication out of the box, whereas with Kinesis, it's quite likely for you to have duplicated events, especially when you consider things like your application may be sending the same thing twice, or maybe it's just something as simple as the SDK doing retries. So SDK retries because you didn't get the response the first time, and then you end up sending the same message twice. So in the past, I've had to build deduplication logic in my application code when I'm working with Kinesis and Lambda quite a few times. Whereas with SQS FIFO queue, you kind of get the benefit of that deduplication based by payload with FIFO queue. And it does work quite well with Lambda nowadays. I do hear you about the throughput limit though. That I do remember that is a soft limit, so it's just a case of asking for a higher limit, but you have to know what you need ahead of time. Whereas with Kinesis, I guess you have a bit more room where you can just well, I don't need to raise a ticket. I just add another shard, and that's it. That's me done. And also at highest throughputs, Kinesis is order of magnitude cheaper compared to SQS. I've had systems in the past where you're sending maybe tens of thousands of messages per second, and when we did the numbers on SQS cost compared to Kinesis, Kinesis was like, I don't know, a couple $100, whereas SQS would have been maybe $10,000 a month. So at the highest throughput scenarios, Kinesis is much cheaper because of the fact that you're paying for uptime. But when you got lower throughput, it gets a bit more expensive when you are paying for uptime, especially when you need to have lots of different streams, one for every egress target.
Yeah, I see. And I also I also had like similar experience with the deduplication, the missing feature in Kinesis. So all of our code has to be idempotent, for example. And it's really hard to test this and to get it right. And in our case, it took I would say it took at least 1 or 2 years until we fixed all the bugs that we had with that, because it's really very hard to test. So all the things that can go wrong and where things are retried and so on. Yeah. So if we could at least avoid inserting the same message twice into Kinesis, that would help a little bit. So I agree that deduplication is a nice feature of the FIFO queues. Yeah.
So maybe going back a little bit about what you said about the Slack and other APIs not being available, not being reliable. Have you done anything around the retrying those requests similar to what the SDK gives you, like the exponential backoff and all of that on top of what you're doing with the Kinesis and Lambda retries?
Yeah, so basically we can say there are two different kind of problems with the APIs. The first problem is they are only very small amount of requests fail, and the other problem is, okay, they really have a big problem on their side and that the API does not work for 10 minutes or so. And to fix the first problems, like the temporary problems, we implement everything in Node.js. So we use there's a very famous, or not famous, a popular library. Like back in the days, the popular library was Request, and basically there is another library that is called Request Retry, that basically gives you the same functionality that the AWS SDK has. So if the HTTP call fails to the Slack API, the library itself will do the retries. So you have to make sure that you configure it in a way that matches with the timeout of your Lambda function. So for example, if the Lambda function timeout is 30 seconds, then you should ensure that your retries will not take longer than 30 seconds, because otherwise the function will time out. But yeah, so I think we do 3 or 4 retries within a few seconds the first time, and then a couple of maybe 2 or 3 seconds, and then 6 seconds, and something like this. So we try to have timers of 30 seconds of the Lambda functions. So that's the first kind of mechanism that we have implemented, and that fixes a lot of problems. This also fixes problems that sometimes your Lambda function has some issues connecting to the internet. So this will also fix that problem. And the other problem where we really have unavailable APIs for hours, and then the Kinesis retry will help us, because Kinesis, in the default configuration, will retry the events as like basically 4 days. So I think we have the retention set to 7 days. So we can retry for 7 days if you like to finally deliver the message to Slack. So far we never needed 7 days. So usually they fix it within a few hours. But yeah, so those are the two ways of retries that we have implemented for making calls to the Slack API. And we have the same thing for the Teams API as well now, yeah.
Okay, that makes a lot of sense. Are there any other sort of interesting technical challenges or features that you had to implement as part of building Marbot?
Yeah, so maybe I can go a little bit into the details about how we figured out like performance problems. So one thing that maybe as a like background information is that if you click a button in Slack, so there are these buttons in messages that you can add. And if you click this button, then the endpoint has to respond within 3 seconds. So Slack will only wait for 3 seconds for a result from you. And at the beginning, we had lots of issues making sure that we can respond under 3 seconds with all the cold start things that, like, I mean, now it's not a big problem anymore, but in 2016, so we had to make sure that everything starts up soon enough that we can respond within 3 seconds. So we did a lot of optimization there. And what helped us is that we added xray. So we now can see, okay, how long does this call to Kinesis take? How long does it take to talk to DynamoDB? But the cool thing about xray is you can also integrate it. And so when we make a request to Slack, we also see this in xray. When we make a call to Microsoft Teams, we also see this in xray. And that's then very powerful because then you really can see, okay, where is all this time spent? Why does it take so long to process the message? So that was really a big benefit for us when we added xray to our setup to investigate a little bit, okay, where's all the time spent in our functions, yeah. Not sure what your experiences are with xray.
Yeah, I find that xray is okay when you've got a relatively simple application, but when you've got something more interesting, especially in the serverless world where you've got a lot of asynchronous processing happening, xray kind of just doesn't quite do the job anymore. If, for example, when you've got Kinesis, it doesn't trace those invocations through Kinesis, so it becomes very, I guess, less useful as you're doing more and more of this asynchronous processing in your system, which is quite normal in the sort of serverless world. So I do find the xray is a bit limited, but some of the other vendors, third-party vendors like Lumigo, Absagon, and Thundra, they do a much better job of tracing other event triggers for Lambda functions and can connect them a lot better. But for simple HTTP to HTTP requests, xray still does the job, I think. Before we jump on the call, you also mentioned something interesting, which is how to implement the timers on AWS, because that's actually a topic that I've written about and also written quite a bit actually in the latest chapter we just released on the serverless architectures on AWS 2nd edition, which I'll be working on with Peter Sparsky. I'm quite curious about which approach you guys went with, because there's so many different ways to do it with SQS, with step functions, using a cron job and so on. I wonder which one you guys actually used.
Yeah, so maybe I add the background information. So why do we actually need it? So when you receive an alert in Slack, we start an escalation chain. So we basically pick one of the online users of the channel. And this user receives a private message where we say, okay, here's something wrong, please take care. And now you have 5 minutes to acknowledge this alert. And if you do not acknowledge within 5 minutes, then we escalate to the next user. And then if no acknowledgement happened again, we escalate to the whole channel. So that's why we need the timer, and it's a 5-minute timer. And we started with the SQS approach. So if you send a message to SQS, you can basically delay the message. So it only pops up, for example, in our case, 5 minutes later. And now I cannot really remember if 5 minutes is acceptable, but I think it's an acceptable. So you don't have to, you cannot delay for longer than, I don't really know the limit here. I cannot remember it. But for 5 minutes, I think it's acceptable. You can just delay a single message. And then remember that in 2016, it was not so easy to connect the Lambda function with an SQS queue. So we had to manage all the polling on ourselves as well. So we had something that triggered the Lambda function to poll the SQS queue. So, and that was, so we basically never acted exactly 5 minutes after we started the timer. But that was not too much of a big deal for us. But still, it was error prone. So finally, we re-architected this piece. And now today we are using a step function, and the step function does very accurate weights, and then it just invokes our Lambda function after exactly 5 minutes. And that's how we do it nowadays, and we are very happy with that. So we don't see many problems. I think it depends a little bit on the number of timers that you have. So I think it's definitely more expensive to use the step function approach. But for us, where we have, so basically for each alert that we have, we can have up to 4 timers. So that's a reasonable number, and the costs are not really a problem for us here.
Okay, yeah, sounds good. Yes, SQS, the delayed delivery, you can only have it up to 15 minutes. And it's still quite accurate from when I tested that, whereas step functions is very precise. When you set a time, specific time is literally precise to like the milliseconds, which is pretty amazing. But step function is a bit more expensive. It's probably one of the most expensive services on AWS. But unless you're using it on massive scale, it probably doesn't matter too much, I imagine. Because even though it's expensive, you're still talking about $25 per million state transitions. So if you just have one state to wait and then triggers Lambda function, well, actually 2 state, then it's not that bad. You can still get a lot done with that $25. But one thing that's actually interesting I found out recently about step functions is that even though the pricing says it charges you based on state transition, it actually charges you for the start and end state as well. Even though those are system states, it's not something that you write yourself. But you get charged for, in your example, if you've got one state for waiting, another state for running the execution, then you have really 4 states: the start, the wait, execution, and then end. They all get charged. The documentation in the official pricing page is actually wrong, and it's been raised to AWS. I think a few other people from AWS are already sort of looking into this now to get it updated. But the pricing example itself was wrong, and I had to find out by creating a state machine in a region that I don't normally use, and then run one execution, and then check like 2 hours later what shows up in my AWS billing in terms of the number of state transitions that get charged. That's the only way I managed to find out that the start and end actually got included in the charge. So that's just something to sort of keep in mind. But like I said, if you're not doing it at massive scale, then step functions may be expensive per unit, but if you're not using it all that much, then it's probably okay.
Yeah, that's a good point, and I wasn't aware of that. Like that they also, like, I would expect that it would charge 2 state transitions in this case that you mentioned, so and not 4. So that's a good thing to keep in mind for, like, if you make a calculation for a project where there's a lot of volume, then I mean this will basically double your costs, and this can be a problem. Yeah, so.
Yeah. I was really surprised when I found out that the pricing example they had in the documentations was wrong. But yeah, it's one of those things that you only find out if you really have to make a lot of effort, because the AWS billing is not real time; it's a couple of hours behind. So I had to wait quite a long time just to confirm this suspicion I had. But yeah, I'm glad that I found out, and now I can have a more accurate estimate for what my step functions cost is going to be. I think you also mentioned another thing before we jumped on the call, that you had some interesting challenges around keeping secrets secure and how you deal with encryption and all of that.
Yeah, so basically the secrets that we have to take care of are, so if you talk to the Slack API, you need a token. If you talk to the Microsoft Teams API, you need another token as well. And I'm a big fan of keeping all of my configuration in the repository as well, like in the Git repository. I know that a lot of people think that that's not a good idea, but I like it. But we don't like to have them in plain text because, I mean, we don't want to have our secrets. We don't want them to be in the Git repository, of course. So what we did is we have a JSON file for our configuration that has 2 values, one for the Slack API, one for the Teams API token. and a bunch of others. And what we do is when we check those files in, we encrypt them using the AWS KMS decrypt command. So we only check in the, we encrypt it. Yeah, we only check in the encrypted file. So it's basically a binary file, so you cannot see any text in here. And then when our Lambda functions start up, they read the file and they run the, like in memory, they do the KMS decrypt, and the decrypted values are never on the system, and they are only in the memory. And then we can access them in our application code. And if the Lambda function shuts down, then the values are also no longer visible. So that was the approach that we have taken. And I think there are now maybe better alternatives, but depending on the number of values that you really have in this configuration file, it might not be a good idea to configure everything over environment variables. So that's why we still use that approach. And the thing that I like is that it's part of the code. So at any time I can actually see, okay, the configuration at like 3 months before looked like this if I decrypt the file, and now it looks like this. So you can also see how the configuration changed. And that works pretty well for us. The only problem is that, of course, if 2 people make a change to this file at the same time, this is not something that you can merge in Git, because it's just like binary data that cannot be merged line by line, for example, in Git. So if a lot of people are working on a project and you only have one of those files that are encrypted, then this might not be a good idea. But in our case, we are only 2 people working on the project. So for us, this is working fine.
Yeah, I think, well, my personal rule is that to never have those secrets in plain text in the environment variables. And so long you can satisfy that, I think that's good enough. One thing I would probably add is that is for secrets that doesn't change often, I think this is perfectly fine. One reason why you may want to use something like SSM parameter store instead is if you want to rotate those secrets regularly using a cron job or something, so that you don't have to redeploy every time that secret change. Which can be quite labor intensive if you have a lot of microservices. That actually happened to one of the teams that I worked with in the past, where we updated the credentials for a MongoDB cluster we were using for dev, and the poor guy had to redeploy something like 50 different microservices. So this is where if you load a cold start from, say, something like SSM parameter store, then you change it in one place, maybe still have them in the source code, but then when you commit, some pipeline then updates SSM parameter store in all the different regions you're in, then Lambda function themselves will have some kind of cache and invalidation mechanism, so that every couple of minutes it's going to go check SSM to see whether or not that's the new version. So this allows you to, I guess, centralize your configurations so that you change it in one place, and all the function will just update without having to be redeployed. For your example, it sounds like you've got quite a few different configurations, and also it doesn't really change. So I think what you're doing makes total sense.
Yeah, so it doesn't change often, that's right. I have one question, because I haven't really used it in the serverless project, but have you used the new service, the app config service? Because I think that would also kind of maybe solve this problem where you want to deploy the configuration separately from deploying your code. But I'm not sure if that's actually used at for serverless projects very often, or what's your experience here?
I haven't used it myself, and I haven't seen many other people use it. The only person I've heard talking about it for serverless projects is probably Ben Cahill from iRobot. I think he was looking into it. I don't know if he's actually using it yet. But app config is not as tightly integrated into Lambda as you would like. It would be great in the future if AWS would make it just something that you configure with your Lambda function, so that with app config you can do all these things around, have a config group that you can have A/B testing and canarying, all of that, which is amazing. But it's not really tied to your application in a tightly integrated way, as your Lambda functions in the tightly integrated way. So all of that have to be kind of done in your application code, and it's just not as easy to read from compared to something like SSM parameter store, I think. No, but there's I guess opportunity there for them to potentially do a tighter integration between Lambda and app config, where you can just point your Lambda function to a config in app config, so that your function will just have access to that at runtime via maybe some environment variable or maybe the context object. But I'd love to see something like that happen, because app config offers some interesting opportunities that you have to build yourself if you were to use SSM or use a secrets manager.
Yeah, I agree. And this was also kind of my, like what I discovered when I just played around with it. And I think like when it was released, it like the only source for a configuration was SSM. And now it can also be an S3 file, which makes it a little bit easier if you have larger files. So yeah, I think we have to wait a little bit and see the improvements of the integration. And then this really can become a powerful tool, yeah.
I guess one other thing I wanted to ask about Marbot is that, have you guys gone multi-region yet? Is that something that you guys are considering in the pipeline?
Yeah, so I'm a big fan of doing this and I'm really looking forward to do it. The problem for us is that it's not really a requirement for us to do it because, for example, Slack only operates in US East 1. So, I mean, if US East 1 is down, then, I mean, we cannot send messages because Slack will not be available. But the more, like, the thing that drives this requirement at the moment for us is that when we switch to when we added support for Microsoft Teams run in multiple regions. So, for example, customers in the United States have a different kind of endpoint than customers in Europe and then customers in Asia, for example. So, and the reason is basically that, I mean, this is kind of personal identifiable data. So we shouldn't process, or we should process this data close to the customer in the same jurisdiction. So that's why we are more interested in this feature today. It's not really about the uptime, but it's about keeping the data close to the users and in the same jurisdiction. The only problem that I have, like when I first looked into it, my problem was that with the first version of DynamoDB global tables, it was not possible to use an existing table with data. And when I looked at this, I don't have really I don't want to migrate all of my data. So that's not something I want to do. So I waited, and now luckily you can use it with existing tables that have data already in the tables. The only problem, and I'm waiting again, is that there's no support for the global tables in CloudFormation. So I'm still waiting for CloudFormation support. And as soon as we see CloudFormation support, then we are going to plan this feature. And I'm looking forward to do it because I mean, in our case, it's more like a challenge for us, technical challenge, but also like from the data perspective, it makes sense for our customers. So yeah, it's not yet implemented, but I'm watching out for the changes that AWS releases. And I hope that I can do multi-region DynamoDB in CloudFormation soon.
All right, that sounds like a AWS wish list item.
Yes.
Anything else that you would like to add to your AWS wish list item here?
Oh, I think we already added a lot of features already. So Kinesis on demand kind of mode would be great, where pay per record and not per hour of a shard. Then the deduplication in Kinesis would be nice, and multi-region in CloudFormation for DynamoDB. I think that those are my 3 wishes for, at least for Marbot, that would help us. Yeah.
Excellent. Those are things that I've asked for in the past as well. It's funny that everyone seems to hit the same problems. Okay, so I think that's all the questions I've got. Is there anything else that you'd like to tell the audience about your next project, things you're working on?
I think the last thing that I might mention is that if you want to try out Marbot, it's free for the first 14 days. So you can go to marbot.io, and there are 2 buttons, add to Slack and add to Microsoft Teams. And as soon as you install it, Marbot will start talking to you, and you will get like a wizard is starting where we ask you, okay, do you want to set up monitoring rules in AWS? And Marbot does all of that for you. So basically, once it is installed, the conversation starts, and we don't only help you with the alerts. Marbot also helps you to set up all the the configuration in AWS that you need, that you actually are notified if things are wrong. So we have over, I think, 50 CloudWatch event rules. So like things like guard duty, security hub, but also the health dashboard events. So there's a couple of sources that are interesting, and we will kind of connect to all of them, and then you will see the results in your Slack or in your Teams window. So yeah, check that out if you're interested. And we would love to see a few of your listeners using Marbot in the future.
Excellent. And with that, I guess thank you very much for taking the time to talk to us today. How can people find you on the internet?
Oh, yeah, that's a good question. So they can follow me on Twitter, and my Twitter handle is hello Michi Bye. I think we added to the show notes to make sure that no one makes mistakes when typing this. They can also find me on LinkedIn, and feel free to connect and send me a message or mention me on Twitter. I'm always happy to chat about AWS topics and serverless, of course, as well. So those are the easiest way to reach me. And of course, you can also find us on cloudonaut.io, where we publish AWS content every week. So those are the easiest way to reach me.
Yep, sure. I'll put those in the show notes and include the links to Marbot, to your blog, to your books, and your courses, so that people can go and find you on the internet and all the content that you're putting out there. So again, thank you so much, Michael, for joining me today.
Yeah, thanks for having me, and have a good day.
You too. Take care. Stay safe. Bye-bye.
Bye.
So that's it for another episode of Real-World Serverless. To access the show notes, please go to realworldserverless.com. If you want to learn how to build production-ready serverless applications, please check out my upcoming courses at productionreadyserverless.com. And I'll see you guys next time.